Hello. Oh, I can hear myself now. Yeah, it's strange. So, so this conference is a little bit special to me because I helped to organize the first edition of this conference, like back to 3 or 4 years ago. I was organizing this conference, so it's quite special. Also, in this conference, I met one of my business partners. Uh, he's a nice guy, so it's really good opportunity to do networking and meet new people, so I encourage you to do it. So this talk is about secrets using machine learning and Go. It's more or less the experience that I have the past 1.5 years. So who I am. So my name is David Hernandez. You can follow me on Twitter if you want. It's not required. I'm Gophers since 2013. I was living in Sydney at that time, and I went to one of the Sydney Go meetups and met really cool people there. And I got hooked into the language since then and tried to do everything in Go. Sometimes it's possible, sometimes it's not, but I try to do everything in Go. I like to contribute with the community from time to time if I have the chance. For example, this year I ran a workshop in GopherCon Iceland, and the workshop was about machine learning. So yeah, quite good experience. So I recommend you also, if you have something to contribute to the community, just go ahead, try it. So what I do, I work for this little startup. It's called Machine Box. We have a super cute mascot. She's called Machina. If you see how she looks like, it's been designed by Ashley McNamara, so you may notice some good patterns there. What we do is we ship machine learning in Docker containers. So we develop state-of-the-art machine learning models, and we put it in Docker containers. So you can deploy and use it in your own laptop or in your company without having to send the data to the cloud or calling external APIs. You can just have it wherever you want, whatever runs Docker, wherever you can have these machine learning models. Yeah, we have face recognition, we have image recognition, sentiment analysis, and NLP, so it's quite cool. So what I want to share is more or less the journey that I had when I was trying to develop these models almost from the scratch. I was trying to use Go. I faced some kind of problems, some tips and tricks that I want to share. But first of all, I want to give a little introduction to machine learning, because maybe some people don't know anything about machine learning, so it's good to know a little bit and see what happened in the world of machine learning. Cool. Let me get some water. And we're going to see some Terminators coming. Sorry. So machine learning is a little bit high. The last couple of years, we've been seeing movies, press, TV, that machines are coming to take over the world, and they're going to kill some humans, all powered by TensorFlow, of course. But the reality is quite far from there. We're not going to see machines killing humans probably in the next 10 years, I guess. Yeah. So the reality is more close to this. Machines are getting good playing games. This was around 2 years ago. It was the game is the ancient game of Go. Go the game, not Go the language. I know it's a controversial thing, but yeah, Go the game. So a team that was DeepMind was a UK-based team. Won this competition with Lee Sedol, that is one of the best Go players in the world. The particular thing of game of Go is that they have so many possibilities. They have many possibilities. It's much complex than chess. So it's quite difficult to apply any algorithms, any heuristics to just make better games. So this team used a technique that is called deep reinforced learning. and managed to win that one. They played like 5 games, and he won. Lisido won just 1 match, and the machine won the race. So yeah, there are 2 things about this one. So the first thing is, you can watch a documentary about this in Google Play and Netflix. It's called AlphaGo. I highly recommend to watch. It's quite fun. It's like a documentary about software development. Probably all of you are into that, so it's quite good. The second thing, in these times of Brexit, they managed to give an artificial intelligence British nationality for some reason. I don't know how they managed. They did the paperwork so quickly. I don't really know. Cool. The other use case that I'm really looking forward to it is self-driving cars. We've been hearing about it all over around. And I'm really looking forward to the day that we can just move ourselves into little capsules and we don't have to worry about owning a car or anything else. Yeah, I think we are quite there. Probably in 1 year, couple of years times, we see more of this. Probably, if it's delayed, probably it's because regulations more than the technology. So it's quite advanced right now, and I'm really looking forward to this use case. But I don't know many people working in self-driving cars. I don't know anyone working in self-driving cars. Anyone here working in self-driving cars? And I always ask this question, never show up. But one day I'm going to have one engineer, that works in self-driving car, maybe. So that's not a common use case. The common use case that many people have is just, I have this content in our site or in our system, and we want to recommend better content to the users. We want to just engage with the user in a more intelligent way. Calculating who is trending now, personalization and content recommendation is a quite common problem in machine learning. So I guess it's more common problem to you. So you probably could work in this type of problems. The other problem that I quite like is this one. A few years back, 1 year or 2 years ago, Google released this feature in Gmail that you can just generate auto responses. And the auto responses look really good. Sometimes a little bit scary. They are too perfect. It's like, I don't write like that. But it's cool use case. It can solve a lot of productivity. You can use it to just do customer support, to solve quickly question and answering that you have in your system. So it's quite common use case, and it really advanced the last couple of years. And the third use case that I want to mention, and I'm really amazed with this use case, is the case for learned index structures. So you may use to this is a paper by some people in Google that they made some research. So you may use B-trees or hash maps to access your database or to just use a cache or something like that. So it's quite common for a programming language to have a B-tree or a map. So the idea here is that machine learning can learn the patterns of accessing the data, can memorize some of the data and do it better than a traditional data structure. So maybe at some point in the future, instead of just using a hash map, once it has maybe 1 million entries in that hash map, you can use machine learning to relearn that data structure and be more efficient in access patterns or just using it in the map. So it's quite common use case. So predicting a little bit the future, maybe in Go 0.3, Go 0.4, or Go++, maybe machine learning is part of the standard library, and you can, the same way that you can use a map, you can use a data structure that is backed in some way by machine learning. So it's quite cool use case. I really like it, and I believe the the research in databases and caches and these kind of things is going to go in this direction. Sure. So, but why is machine learning popular right now? What happened the last few years? So what happened the last few years is neural networks. Neural networks, the theory, was there for a while, since the 70s. But nobody used it till 2012. They were using more classical algorithms to do machine learning, like SVM, that is support virtual machines, or methods based on trees, like random forests and so on. So in 2012, in this competition that is called ImageNet, a team of researchers, they managed to train the first deep neural network. And what does it mean? It's a deep neural network. So the theory was there since the 70s, but given that it was computationally expensive, and there was some tricks that they applied to execute the code faster in GPUs, they managed to train it. And they achieved incredible performance in this competition. This competition was about classifying around 1 million images in 1,000 different classes. Classes means like, oh, is this a dog, is this a cat, is this an elephant, and so on. So since then, everybody started to use deep neural networks to any kind of problem. So they started with computer vision, but later on they do it for machine translation. So you use just a neural network to do all the machine translation from up. The amazing thing is you can fit any kind of language in the output, any kind of language, well, almost any kind of language in the input, and just do a neural network that it translates from English to French, from English to Spanish, and it's the same one. So you only need to change the data. So that's quite amazing. That's the sequence-to-sequence models, and it's really good, and it's using the same techniques. So yeah, neural networks are really popular, but there is a perception that, oh, what can I do for me? So it's quiz time. I know it's controversial. In UK, we don't like to collaborate with people sometimes. So that's a difficult problem to solve. It's just quite interesting machine learning problem. It's the famous Chihuahuas versus muffins. So please raise your hand if you think it's a difficult problem for machines. Yeah, okay. Raise your hand if you think it's really easy. It's just a solved problem. Nobody? I raise my hand. So it's a funny problem, but it's really easy to solve. Machines doesn't have any problem to solve that. So any neural network these days, even if you download from internet and it's a pre-trained model, it can distinguish very well if it's a Chihuahua or it's some kind of food. It wasn't trained this neural network on muffins, but it says, custard apple. So yeah, they get it 100% of the time. So the next time that you visit a robot coffee shop, and a robot serve you a coffee and a muffin, you are okay, you're gonna receive a muffin, you're not gonna receive a Chihuahua. Cool, so, but now, how can I use this in Go? How can machine learning help me in my day-to-day job? So I'm gonna try to explain or to give some advice about the tips and tricks and secrets about deploying models in production or trying to using models. So let me get some water, please. So you may guess the first advice. The first advice is quite simple. Sorry. So the first advice is use Python. Don't be a Wonder Woman. Don't be Batman. Around 90% of the people doing machine learning is using Python right now. So So if you use Python, you're going to get more support from whatever you're looking for. So yeah, if you are especially if you are starting in machine learning, use Python. It's probably the right tool for the job. Also, you may already have in your team a group of data scientists or machine learning engineers, and they may be just doing Python code. So it's completely normal. So most of the people does it right now. We will see later how come maybe do it in Go. But now, let's say that you want to use Python. So my recommendation is use scikit-learn if you want to start. It's a really good framework for just machine learning in general. If you want to use or try to use neural networks, that is quite fancy right now, I recommend starting with Keras. Keras is a high-level API on top of multiple frameworks, and the usually backend that you use is TensorFlow. That's a lazy Gopher there. So don't start with TensorFlow directly. The API is absolutely horrible. It's low level. So unless you are really, really sure what you're doing, Keras is much easy to get started and do cool things quickly. So once you have your model in Python, for some reason, you want to use that model in production. So my recommendation and 5-minute job is just wrap your Python code with HTTP framework like Flash and use Go HTTP client to connect. That could get you a little bit far. So the first version in Machinebox that we did to proof of concept, to try, was just that. Nothing else, nothing more. As an MVP, it's a good solution. But you may not want to pay the price of an HTTP request, or you may want to package in a different way. So the little secret is that the Python interpreter is written in C, so you can actually invoke Python from CGO. And there is this library that is called GoPython by Sebastian Binet. That's actually a real photo of Sebastian. That it wraps a little bit CGO, and you can call Python. So let's see a little example. So you only have to, as usual, import Python, initialize Python. You can defer the finalize if you want. And basically, executing Python, you can do it in line in this stream. Also, it has some utilities to call methods, retrieve back the results. So it has some little tools to convert from Python to Go and the other way around. So that's probably a little bit more advanced than just wrapping your Python code with an HTTP. But yeah, that actually works pretty well. If you want to find out more how to wrap Python, there's a really good blog post in Datadog. Datadog, they use this library to instrumentate the library that they have for collecting metrics. They have some sort of Python plugins, and this blog post entry is quite good. I recommend it to read it. The other way around, so you may want to use the cool framework that is TensorFlow. So there is a CGO library that you can use, so you can actually use TensorFlow directly in Go. My recommendation is as follows. So basically, don't train your model in Go. Use Python for it. Especially with Keras, it's really easy to train. The library in Go is not very idiomatic. You're going to lose your time converting, typecasting, and so on. So if you want to write probably 100 lines of Python instead of 200 or 300 lines of Go, the quickest way is just train your model in Python, use Keras for it, and that could be really good. So the next thing that you have to do is name your input layer and your output layer of the neural network. So you can know what to feed to the network and what to get out from the network. And basically save it to this. Once you do the training, since then, with the model saved to this, you can basically use it in Go with TensorFlow. Let's see an example. So you import the TensorFlow library. As you see, it's not very idiomatic. It's like finish up in Go that it doesn't make sense because we know it's Go. So the only thing that you have to do is load the model, and it's going to be loaded in memory. And when you finish using the model, you just defer the close session, and that's all. This is a news classification model. It classifies news in 20 different categories. And to run this model, you have a method in the model that is called run. And you basically feed a tensor that is a bunch of numbers to the input layer that you named before when you train the model. You get the output from the output layer. That is the same name that you use when you train the model. And basically, you run that, and you get the value in one strange variable that is called results. As you see, it's not very idiomatic. It's not really fun to work with this library, but it works. And basically, this is mostly the only thing that you have to do. I have a complete example working, like, I'm going to train my model with Keras, save it to this, run it in Go. I did that for the workshop in GopherCon EU, and the code is public. You can check it out if you want to train it yourself and call the model yourself. Yeah, please do it. So the two tricks using TensorFlow in Go and probably any intensive computing task is these two little things. Just limit the work in progress. So running a session in TensorFlow could be expensive, especially if you're treating images. It could take 1 second, 2 seconds, even 10 seconds if you are doing, I don't know, face recognition in 200 people, in a photo of 200 people, maybe take up to 10 seconds. So it's an intensive task. So there is no point to run it if the request has already canceled, for example. And you don't want to saturate your CPUs. If many requests come in and it's already busy, you don't really want to execute another request and make the things worse. So for that, I have like little code that is quite cool, and it's this runner. This runner uses a buffer channel to limit the work in progress to the number of jobs that you pass as a parameter, and it does two little things. So this run protects that function with a semaphore in that buffer channel, but the other cool thing is, if the context is already done, I return context error. So with that, I do the two things, limiting the work in progress and failing quickly. To use it in a more complex environment, this is a model that it extracts features from an image. If you see, the session run is a little bit more complex than the other one, but essentially it's the same. What I do is also wrap it in that run function, so I protect myself from disaster. But the code to run TensorFlow models is basically always the same. It's just a run, I pre-process the input, and post-process the output. So you basically have to convert whatever input to a tensor, and from a tensor, convert that to a meaningful result, like a category or whatever you're trying to achieve. Cool, but there are many other frameworks and cool libraries that you can use. maybe there is not a way to write it in Go. So basically, the cool thing is you can use CGO to wrap any C and C++ library. And this is quite cool technique. So the warning is CGO is not Go, so you may be scary, it's more error prone, but it's possible. You can do it with few lines of code. A cool project that does that is OpenCV. So OpenCV has a wrappers in Go, and they using cool patterns to access C++ directly using CGO. Let's see an example. So for example, I want to use a C++ class that is matrix, and it's called CMat, is the one that I try to store. So the rule is very simple. Every time that you try to use a C++ class, you wrap it in a Go struct, and you store a pointer to that struct. So the only thing that you have to do is from C, you allocate a new pointer in new and assign it to it. And to free the memory, you only have to call close and set the pointer to nil. So if you take into account this, you can basically use any class in C++ with the new and defer close. You're going to be safe. You're going to be always freeing the memory. So it's quite cool pattern. And you need .h header to just be able to define the things that you need to call and the things that you don't. So for example, with this little bit boilerplate, you can put the bridge between C and C++. You can define that object that is basically a bridge between the library and CGO in C++ and in C, and the functions that you're going to use to use it. So it's quite simple pattern. So don't be scared to use it. Just the recommendation is just use the things that you need. Don't try to make a wrapper to the whole library. Just if you have to use one class, just use that class, make the wrapper, and call that class, and that's perfectly fine. Cool. Now the most interesting part. What about if I want to do machine learning in Go? Is it possible? Do you think it's possible? Everything is possible. So there are good libraries in Go as well. So for example, I'm going to do three of my favorites, and the first one is GoNum. GoNum is a really good library. It's rock solid. It's production ready. So if you want to do numeric computation, for example, linear regressions, things like that, it's quite good. The API is very idiomatic, and it's good. For example, with GoNum, you can easily multiply two matrices. And the API is quite nice. So you can define a matrix, the 3 by 2, put some numbers there, define the second matrix, also 2 by 3, so you can able to match and multiply. And the third matrix with this dense, you can just do C, mult, A, and B. And it's quite idiomatic, quite nice. So with these primitives, you can easily build a linear regression or whatever you want. And it has, the library is a little bit big, has different packages, so I recommend you to have a look. So that's a little bit low level, isn't it? So there is another library that is called scikit-learn. I guess it's the same name as in Python one. So it tried to replicate all the functionality that the one in Python has. And this is more higher level. The thing is quite recent and new library. So there's a lot of work in progress. I encourage you to check it out. They have cool examples, but the API could change. So have a look, especially if maybe you're coming from Python and you want to see the equivalent, and this is a good place to start. so I'm really looking forward to this project. It's looking really nice. But what about if I want to use GPUs and neural networks? So there is this project, Gorgonia, that is basically the equivalent of TensorFlow in Go. So, so it's really good project. It's, for me, it's a little bit low level as TensorFlow it is. So a high level API, it will help a lot in adoption. So probably in 1 year time, we have the same level of confidence that I had when I trained my model in Keras and deployed it in CGO and TensorFlow. So you can do GPU computations really good in Gorgonia, but to do high-level models, you're probably going to struggle a little bit, at least right now. They are improving that, but it's taking time. Yeah, if you are a fan of GPUs, computation, I encourage you to collaborate with this project. The main author is really nice. What about if I want to learn more? I want to learn everything about machine learning in Go. So yeah, there is a good resource. This book by Daniel Weinach has a lot of examples from how to parse a CSV in Go, how to do a linear regression, how to run a classification algorithm, and all implemented in Go. There is all Go code. He does a neural network from the scratch, so you can actually, if you want to know how the internals works, you can read it. I recommend you to have a look to this book. And last, if you want to do data science in Go, Gopher Data.io has a good repository. It has a Git repository of a collection of libraries for many different tasks. You can find resources how to do NLP or process or do a stemming in text. So it's a good resources for just having a look and say, oh, I need this library that looks a little bit data science, so what I should check. So go to Gopher Data and have a look at the recommendations. They are really good. Most of the people are writing here are the maintainers of the library, so it's quite good. Yeah, this is the 5 kind of secrets. So the first secret, if you remember well, is just use Python, especially if you are new. If you are not new, you can overtake the rules. The second one is wrap Python effectively. You can do it in 2 different ways. Probably calling with that CGO library is quite good chances to do it. The third one is using TensorFlow with CGO is a reality. We serve models in production with that technique, and it really works well. So you can do it. The fourth one, if it's a C++ library that you want to use for numeric computation, for computer vision, and there is no way to just call it from Go, using CGO and C++ is a reality. It's a little bit difficult, but not impossible. And follow a couple of patterns. You can make it. You could make it easy. And the last one is just Go is starting to be a reality when you do machine learning. The advantage of Go is just it's very close to production, so you probably not have problems that I have before running Python models, because it's just Go native, so it should be performant, isn't it? So thank you very much. I'm happy to take any questions. Any questions? I also have stickers from Machina. So if you want a sticker, you can just ask me, and I give you 1 or 2. Yeah. Yeah, tell me.
Which of any of those techniques did you use at Machine Docs?
Yeah, so at the beginning, we just have some Python code, make the wrapper with HTTP, and just deploy it and call it. And later on, we moved to just use the CGO wrapper, and later on, we moved to just deploy the TensorFlow models in CGO. And after that, we did some experiments using CGO and some C++ frameworks. So we basically did everything from 1 to 5, basically. So that's more or less the experience. Yes?
Do you have any recommendations around data set size and minimum data set size for training?
Yeah, sure. So the general rule, and it really depends of the model that you are trying to train. For example, text classification, you can start to do a text classifier with 100 examples per class. For example, you have spam versus not spam. You have 100 examples of spam, 100 examples of not spam. You can just start as a little as that. There is a myth that you need 1 billion messages. No, you don't. For basic machine learning, you just need a few hundreds. The important thing is that the classes are balanced. Yeah, see, so if you have just one example of spam versus 1,000 examples of non-spam, you cannot learn anything from that. So it's good to have balance in your data set. So you have, you basically remove biases in machine learning. Cool. Any other questions? I love questions.
I have one.
Okay.
So you were showing us the problem with the Chihuahua and the mapping.
Yep.
Like from all the boxes that you did, what was the most problematic one and why?
Well, I don't find problematic machine learning problems. I find problematic people. So the problem in machine learning is never 100% accurate. And that means that you have false positive and false negatives. And when you do, for example, face recognition, you go to a customer and say, oh, I have the face of my wife or the face of my friend, and it doesn't work. It doesn't recognize my friend in this photo. I say, oh yeah, and they report the bug. Basically, oh, there is a bug. Can you fix it? And then you can say, oh, it's a false positive. I cannot fix it. You have to learn to deal with, I don't know, 10% of the data that is going to be false positive, and the people still think it's a bug, because we are so used to report bugs and things not working. But with machine learning, it's not going to be 100% accurate. So that's the main problem. Yes.
In that particular case, can you install kind of a feedback loop where you use the false positives and join them with learning data sets?
Yeah, exactly. Yeah, exactly. So the ideal case in your system, it has keep the human into a feedback loop. So you just show something to the user see, oh, this is wrong. So the users try to annotate the photo or try to classify this in other different categories, so you get back the feedback and you improve the data set. So you're starting to minimize that cases. Also, the data changes around the time, so you constantly need to feed that loop. Otherwise, your model is going to work for a couple of months, but not for forever, basically. But that is a weird use case. Most of the people think, oh, I do this model, I'll deploy it, it works forever. And you're going to still have false positives and false negatives. That problem is not removed. It's just going to be delay, basically. Cool. Yes?
Do you know if there are any attempts to bring any learned data structures to Go?
I don't know. I don't think so right now. So maybe it's a good project for research. Yeah. So the learned data structures come from Google, and I think they try it with the data store. They try to change B trees to to machine learning, to just learn data structures. I quite love that use case. Yeah, it's quite cool. Yeah. More questions? Are you sure? You have one more chance to ask more questions. Yeah. You can always talk to me after. I love talking with random strangers, especially about machine learning. So yeah, thank you very much.